Alright, in this video I want to show you how to graph the reciprocal functions, meaning secant, cosecant, and cotangent. And there's a couple ways you could do this, but I think the easiest way to do it is to graph whatever reciprocal of that function is. So if I'm graphing cosecant, the reciprocal of cosecant is sine. I'm just going to use sine to help me graph that. I'm basically going to graph sine and then just do 1 over each of those points. And here's what I mean by that. If you know that the sine is equal to 1, that means the cosecant is going to be 1 over that, or 1 over 1. If you know that the sine is equal to 1/2, that means the cosecant will be the reciprocal, will be 2. So the easiest way to do this is just to graph sine and then use that to help us. And the other thing to keep in mind is like we saw in those pictures, there's going to be vertical asymptotes whenever these equal 0. For example, if sine equals 0, that means cosecant is going to be 1 over 0, and that's undefined. So let's start by graphing our values, or graphing our reciprocals like we did before using these steps, and then we'll be able to get a good picture. So our first step says make a table of values with 5 points, and here's what we want to graph. We want to graph 1/2 times the reciprocal of cosecant is sine. So we're going to graph this right here. Okay, the starting point is whatever makes the parentheses 0. So in this case, the thing that makes this, there's no parentheses there, but now there is. The thing that makes that 0 is just 0, so I'm going to put in 0 right there. And then we want 5 points because on a circle, there's a circle right there. There's 1, 2, 3, 4, and then back at the start, there's 5 significant points. Okay, and then the next 4 should be increasing by the period divided by 4. Remember, the period comes from 360. For sine, it's 360 divided by that number. Okay, so in this case, the period would be 180. 180 divided by 4 is going to give us 45 degrees. So we'll increase this by 45 degrees each time. So 45, 90, 135, and then 180. Okay, and then we just have to plug these into this right here. So y equals this. And that's going to be 1/2 times the sine of 0, because 2 times 0 is 0. Then 1/2 times the sine of 2 times 45 is 90. This is going to be 1/2 times the sine of 180. This would be 1/2 times the sine of 270. And this would be 1/2 times the sine of 360. Okay, and we said that we're supposed to get those measures showing up because those are the measures of the angles on our circle. Alright, so the sine of 0 is 0. And we'll graph sine in red, and we'll graph cosecant in another color so we can see. So this equals 0. This also equals 0. This one is 1. Sine of 90 is 1, but times 1/2 would be 1/2. Okay, this is going to be negative 1/2, and then we're back where we started at 0. So our points are going to be at 0, 0, and then at 45 degrees, comma 1/2. So that's about right here. And by the way, these are going up by 30 each time. We went from 60 to 120, so that means in between must be 90. So 45, 1/2, then 90, 0 is right here. 135, negative 1/2, so this is 1, in between 120 and 180 would be 150. So that's 135 is going to put us there, and then 180 back at 0. So there's our sine graph. That's one complete period of sine right there. So to get cosecant, we'll do cosecant in blue. We're just going to do 1 over each of these. So let me just move this over for a second. Actually, I'll put them right down here. So cosecant is going to be cosecant of 2 theta, 1/2 times cosecant of 2 theta. It's going to be 1 over each of these points. Okay, so we're still going to have those same degree measures. We'll still have 0, 45, 90, 135, and 180. Just like so. And then it's going to be 1 over 0, which means it's undefined right there. This one is also going to be undefined because, again, we're taking the reciprocals of these. So anytime we have a 0 for sine, it's going to be undefined for cosecant. So it means we're going to have asymptotes at 0, 90, and 180. So let's put those right here. So there's 0, there is 90, and there is 180 right there. So there's our 3 asymptotes. And then we have at 45 degrees is going to be 1 over 1/2, which is 2, and 1 over negative 1/2 would be negative 2. So 45 degrees 2 would put us right here, and 135 negative 2 would put us right here. And then the graph in between, you probably remember from the picture before, the graph in between is just going to look like this. You don't really need points other than those. If you want to just have it more accurate, you can. But really all we need to see is that we've taken this red graph and the blue graphs show the reciprocal of that. So that's how you graph cosecant. All right, let's try. If you haven't tried it, I encourage you to pause it and try to graph cotan of pi over 3, or theta over 3, I should say, as well. All right, so this one, first thing we need to know is tangent. This is going to involve using the graph of tangent. And tangent, we want to graph 3 times the tangent of theta over 3. Tangent has a period of 180, so this stuff over here doesn't quite apply. Tangent also has, remember too, that tangent is sine over cosine, so it's undefined whenever the bottom of this fraction equals 0. In other words, whenever cosine is 0. And cosine equals 0 at 2 places. It equals 0 at 90 degrees and 270. Because if you look at this circle right here, cosine is the x-coordinate, and the x-coordinate is 0 at those 2 purple dots. So we're going to have vertical asymptotes at 90 and 270. But remember, cotan is the reciprocal. So the reciprocal of sine over cosine would be cosine over sine. That means this one is going to have asymptotes whenever sine equals 0. So sine of theta equals 0 at 0 degrees and 180. So let's figure out how to set up our table. And the rules are a little bit different from here. We don't really need to follow the same pattern as the other one. What we want to do is find the period. So the period of tangent is 180. Okay, so that means this period right here is going to be 180 divided by, that's 1/3. That's like 1 theta over 3. So 1/3, that's equal to 540 degrees. So the period is going to be 540. Again, this starts at 0 by plugging in 0 right there. So that's going to start us at 0. And then 540 divided by 4 is 135. So let's go up by that each time. We don't have to do it this way. This is more the procedure for sine and cosine, but we will do it this way just to keep it consistent. Okay, and then we know that we're going to have asymptotes for tangent. So we'll graph tangent first, and then cotangent, we could just do 1 over that. So here's our separate part of the table right here. So this is going to be for cotangent, for 3 cotangent of theta over 3. And once we have the tangent values, it'll be easy to find these right here. All right, so we'll plug in 0. So 3 times the tan of 0. Well, remember, tangent is sine over cosine. So that's like sine of 0 over cosine of 0. Sine of 0 is 0, and cosine of 0 is 1. So this is just equal to 0 right here. So you're going to have a point at, let me just clear some of this writing off from the other problems so we could see it a little bit better. We're going to have a point, first of all, at 0, 0. And that means this is going to be undefined. So we'll graph that shortly. Let's get the tangent graph first. Okay, 135, when we plug in 135 right here, we're going to have 135 divided by 3 is 45. So that's going to equal tan of 45 is 1, so 3 times 1 would be 3. That means this is going to be 1 over 3. So 135, and by the way, you can probably tell if we're going from 180 to 360, that's in two positions, we're moving 180 degrees. So that means each one must be going up by 90. So this is 90, 180, 270. So 135 is going to be in between 90 and 180, so approximately right here. Okay. After that, 270, so 3 times 270 divided by 3 is 90. Tan of 90 is undefined, so there's going to be a vertical asymptote at 270 degrees, which is right here. Okay, so we have a vertical asymptote right there. And then at 405 degrees, 405 divided by 3 is 135. And once again, 135, tangent of 135 is like tan of 45. So it's equal to 3. That means this is 1/3. By the way, this one right here, if when tangent is undefined, this is going to be 0, because right here, undefined means you're dividing by 0. You can see the connection here. When that was undefined, this is 0. So that means when this is undefined, that's going to be 0. They're reciprocals or opposites. And then finally, we plug in 540 divided by 3. That's 180. And that's again equal to 0. So this is again going to be undefined. Okay, so let's graph 405. So this is 360. That's going to be 450, so 405 is in between those two, and that's going to put us up at 3 again. And then at 540, we're back at 0 once again. Okay, so 540 divided by divided by 3 would be 0. And actually, just one mistake I noticed, tan of 135 is actually -1, so 3 times -1 would be -3. That's why this picture is not coming out quite like we would expect. So this should be down here at -3. Now it looks more correct. And then notice the period is 540, so that means if we have an asymptote right here at 270, the next asymptote will be 270 plus 540, and that's 810. So we could just put another asymptote here if we want a slightly more accurate picture. But anyway, the graph of tangent is going to look like this right here. It is periodic, it does repeat. So there's tangent. Let's try to get cosine or cotangent. I'm sorry, we'll do that in red. So they're going to have asymptotes at 0 and at 540. So the red line is an asymptote right there, and 540 is another asymptote. You can see it's going to look very similar to tangent. Then at 135 degrees we have 1/3, so that's going to be about right there. And then at 270 degrees we have 0, so that's right there. And then at 405 degrees, same thing. This should be -1/3 right there. So 405 degrees will be -1/3, and it's going to look roughly like this right here. Okay, that red line is the graph of cotangent.